This is session volume 4, locus and its equations in trustee classes. Here we will solve another problem, but different type. Question given here is, find the equation of the locus of a point which moves so that its distance from the x-axis is 3 times its distance from the y-axis. This is the condition given. You can see, find the equation of the locus of a point which moves in such a way or other that its distance from the x-axis is 3 times its distance from the y-axis. This is the given condition. We have to form the equation of locus satisfying this equation, satisfying this condition. Let P xy be any point on the locus. Suppose this is your x-axis and this is y-axis. We have taken a point P whose coordinates are xy. The condition is this distance from P to M is equal to 3 times the distance, that is Pn. That's the given condition in the question. So, what we have to do, we have to draw Pn. We have drawn perpendicular from P to N on y-axis and from P to M on x-axis. Okay. Now, the point P will lie on the locus if and only if the distance of P from x-axis, the distance from P to x-axis, that is y, is 3 times distance from y-axis, that is distance from y-axis, this Pn, that is x. Just repeat again, because sometimes it becomes difficult to understand. So don't get confused at any level. Repeat again and again so that there would not be any chance to forget or get confused. Let P be any point. We have chosen a point which lies on the locus with the condition that this distance or this length is equal to 3 times of this distance. This you have to clarify in your mind. Otherwise, there may be a problem. So, the point P will lie on the locus if and only if. It has been emphasized here that if and only if. If this condition is not fulfilled, then the locus will be different. So, this question says the point P will lie on the locus if and only if. Or you can say the point P will only lie if this condition gets fulfilled, that this distance is 3 times of this distance. So what we have to do is, we have to write this equation in mathematical form. This distance PM, that is distance in the figure, just see. The value of PM is here, value of PM equal to 3 times that of the value of PN. The same thing or same condition is given in the question. We have to just write the same condition in the mathematical form. This is very preliminary step to solve such type of problems. Now put the value of PM. This is PM. This value is Y. So we have written in place of PM Y. Similarly, in place of PN we have written as X. You can see here this PN is equal to X. So similarly write down X in place of PN. It is clear? Now on squaring both sides, what we will get? This will give y square and this will give 9x square. Just to remember, in future you can write down by squaring both sides we get. Sometimes it becomes difficult to remember whether or how this step came here, appeared here. Now you can just repeat once again, since it is a new type of question, so I think you must clarify each and every point. Find the equation of the locus of a point which moves so that its distance from the x-axis is 3 times its distance from the y-axis. Now I think you can note down and understand it very well. If we have taken a point P on the locus, marked distances as per coordinate, PM and PN are the perpendiculars on the axis. The main thing here is we have to not forget that the condition must be fulfilled in each and every case. Whatever is the condition given, it is not necessarily that the condition of this will be same in each question. In every question there will be different conditions, 1 or 2 conditions or more conditions will be there, but we have to comply all these to get the mathematical form. The main thing is to understand the problem, which is written in the form of a story, and that story is to be converted into mathematical form. If this mathematical form is as per given condition, then, or if and only if, I again repeat, then you will get the correct answer. So, wish you all the best that you will solve the problem keeping in mind the This my advice. Okay.